Hello everyone, welcome to STA 2023, Introduction to Statistics 1. Today, we're going to be introducing the topics and concepts of statistics, specifically key terminology and definitions, and while we look at an overview of statistics and our types of data that we're going to be using. Now, you already may be familiar with many of the practices of statistics, things like taking surveys, collecting data, and describing populations. What you may not know is that collecting accurate statistical data is often very difficult and can be very costly. An example of this is every 10 years, based on the rules of the Constitution, the United States has to do what's called a census, where it has to go and collect information for every person living in the United States. And this takes years. It takes thousands and thousands of people, cost a lot of money, and it's very difficult to do. And even still, people still get missed by this census. So sometimes getting this accurate data and getting enough of it can be very costly and difficult based on the amount of resources you have. So if you're a single researcher or a small team, this may just not be possible for you. And we're going to talk a lot about what methods we use in statistics to try to deal with these facts. So first, let's talk about what is the definition of statistics. Now, statistics does not have a specific, unique definition. So on this slide here, you'll see that I've actually collected a few that I think can kind of encapsulate in general what statistics is. So statistics is the study of how to collect, organize, analyze, and interpret numerical and/or categorical information. Definition 2, it is a science of collecting, interpreting, and representing data. Definition 3, it is a language or a mechanism for creating and communicating quantitative concepts and ideas. Number 4, it is a science of decision-making in the face of uncertainty. Number 5, statistics is a way to collect information out of data. And number 6, it is a mathematical science pertaining to the collection, analysis, interpretation, and presentation of data. Now, you may notice the big underlying feature of all of these definitions is that they're based around one particular thing, which is data. Statistics at its heart is about data, and it's about all the aspects of data, from planning how you're going to collect the data, collecting the data. Once you have the data, what do you do with it? How do you store it? How do you transform it or manipulate it or change it? How do you set it up in a way that you can then do your analysis? Doing your analysis. Once you've done your analysis, what do you do with the data? How do you present your data? Who do you present it to? And these are all aspects we have to consider in statistics, which is the field that encompasses everything that is data related. So the definition from your book specifically is that statistics is the science of collecting, organizing, analyzing, and interpreting data to make decisions. Now, this one is important because one of the key aspects of statistics is that we're doing it for a reason, and it's specifically to draw some conclusions or make some decisions. We are not just collecting the data for the sake of collecting it, but we are collecting it in order to be able to make some decision and do something with that data. Now, an aside here that I want to point out is some of the things people love to say about statistics is that you can make statistics say anything you want. We have the quote saying that there's lies, damn lies, and statistics. The problem with these is that statistics is trying to accurately say something about a population using some sample data. So in the end, if you are doing those things, for example, getting the statistics to say what you want, you're not actually doing statistics, you're just lying in a very sophisticated manner. In fact, statistics is mostly about focusing on how do we accurately say something about the population from our sample. And even though there's always going to be some amount of unknown, what steps can we take to try to limit it as much as possible? Now, our parts of statistics are our collection of our data. We've got the analysis of our data. We've got the interpretation of the data. We've got the presentation of the results, and we've got decision making. So for collection of the data, this is broken into a couple different parts. First, we have planning the collection of data. So in this case, we'll want to define the goal and our collection method, right? What is the goal of this statistical study? Why am I collecting this data? Who do I need to collect data from? And what method am I going to use to get the data to be representative? Because remember, the whole point of this is that we want our data that we do collect to be accurate for us to be able to then make some decision or draw some conclusion. Now, for our analysis of data, this is broken up into three main parts of statistics. We've got descriptive statistics, we've got exploratory data analysis, or EDA, and we've got inferential statistics. Now, descriptive statistics is exactly what it sounds like. It is the statistics that describe the data. So, for example, this might be things like mean, median, or mode, which are called central tendencies. Where is the data located in data space? Then you've got things like variability measures. Once you know where the data is, how spread out is the data? It could also be things like its skew. These are things that describe the data that you actually collected. So next, we have our exploratory data analysis. Now, this would be things like where you try to understand what the data is telling you. So this isn't like some movie where you see math, right? If I just see a wall of numbers in some Excel spreadsheet, this doesn't mean anything to me. So what we're going to do is things like create graphs. We're going to look for patterns or trends in the data. We're going to look for what are called outliers, which are data points that fall outside of what we would expect for the data. And we'll look at things like relationships between our variables. So these are all things that are describing the data we actually have collected. Now, this is different from inferential statistics, where we are then trying to use that data that we have to infer or say something about usually a population or even possibly make a prediction about future data. So this case, we'll be looking at estimation, things like point estimates and confidence or interval estimates. We are looking at hypothesis testing, where we will have some hypothesis that we are going to test to see whether the data supports our claim or not. And it could also be things like generalizing from a sample to our population, right? So we get this data, which is from sample, and we're trying to then infer something about the population. So next we have the interpretation of the data. So first we want to understand our results. We want to contextualize the results and assess any limitations that we may have. And we also want to draw conclusions and evaluate the impact of those conclusions. So first, for understanding the results. This is a key aspect because once you've done your analysis, you then need to determine what does it actually mean? How strong does it support whatever it is that you found? You also want to consider contextualizing results and assessing limitations. Now, I wanted to really focus on this one because once you've assessed your results, right, how reliable are they? Should we trust them? Do we need to get more data, do another study? The big thing here would be your limitations, because just because you get results does not mean that they are necessarily reliable, right? What method did you use to interpret your data? What type of data did you get? Is your data representative of the population? Things like that. Next, once you have drawn your conclusion, you will want to then present your results. So you'll have things like choosing the appropriate format to present your results. Your data visualizations, you'll have highlight key results and tailoring presentation to your specific audience. So for choosing the appropriate format, this would be things like, do I want tables? Do I want graphs? Do I want to have a text summary? And this is, again, going to be dependent on who are you actually trying to present the results to. If you're a scientist and you are trying to present to other scientists, you would likely want to have some sort of academic article that's written, meaning that you're going to have a lot of written up text of the summaries about the study you did, the data, all that kind of stuff, your analysis. You're going to have tables included, you're going to have graphs. But if you're working, for example, in a business world where maybe you're trying to create a slide deck to present to some management, then you might not want to have a lot of text and you want to focus a lot more on graphs and maybe key figures, things like that. You might want to have some tables, but you probably want to limit them in scope so that they're very quick and easy for somebody to get an idea about what the data is saying. So for data visualizations, these would be things like bar charts, pie charts, histograms, things like that. Any way that you could visualize the data to make support whatever claim it is that you're trying to make. Now, for highlighting key results, this could be things like emphasizing important trends, patterns, or findings. This could also be something like using annotations or callouts on graphs in order to draw someone's eye to a particular thing that you want to show them. This also could involve summarizing key statistics, right? Because you may have actually gotten a lot of statistics while you were exploring your data, doing your descriptive statistics, but you may want to focus on very specific key descriptors of the data for whoever it is you're trying to show. And then next we have tailoring our presentation to our audience. This one is mostly going to be focusing on the fact of who are you actually trying to give your data to in some form that they can actually use. Again, if you were giving it to scientists, you'll probably want it to be very technical. You'll probably want to have a lot of detail, and you also oftentimes will actually have the data available so that they can dive into it and see if it seems to hold up. If you were using this and you're trying to describe the data to someone who is non-technical, then you would probably want to use something that's more easily understood. Things like graphs and charts, maybe very simple tables, things like that. You may want to describe in layman terms what this is telling us, right? For example, if I see an article in some newspaper about some scientific study, they have probably put it into terms that are not very technical, which is versus the actual study itself, which is probably available to us, might be much harder to get into because it's so technical. So the next thing we had is decision making, which is once you've done all this, what are you doing this for, right? So what's the decision that's made? If you're in business, this may be things like what to do next. It might be how to deal with some situation. If you are in science, it might be what is the next step from this? What are the implications? And what does this mean for your group, society, or whatever it is that you're doing it towards? So once you've done all this, you should be able to make some conclusion, and then from there, determine what is the relevance of this. Okay, so now let's talk about data. So as I said with our definitions, data is the crux of all of it, right? All of those definitions focused on data, collecting data, analyzing data, storing data, interpreting data, presenting data. Data it consists of information coming from observations, counts, measurements, and responses. So it is not defined by where the data comes from. It is just a collection of information, whether it be from a survey, whether you were observing something and then tallying it, whether you're getting a count of something. For example, how many cars park in the parking deck on Wednesdays? Okay, so we have a count. You stay there with a tally and 1, 2, 3, you count it up. Measurements, how much rain falls in the month of May in Seattle? Or responses, if I have a survey, how many people responded favorably to this? So these are all things that the data consists of. It's just information based on whatever it is that we are trying to say something about. Now I want to note one thing. I oftentimes will use this incorrectly, but data is technically plural. The singular of data is datum. So if you have a single data point, it is called a datum. I typically use the term data point. Data represents more than one. It's a plural. Okay, so now a couple big definitions we're going to be using throughout the course is population and sample. So population is a collection of all outcomes, responses, measurements, or counts that are of interest. Now, I'm actually going to push back on this definition a little bit. This is the definition your book uses, but a population is not measurement, responses, counts, or any of that kind of stuff. The population is the group of interest that you are getting your response, measurement, count of it, stuff like that. So basically what this means is, if I'm looking at Americans, okay, well, first of all, how do we define Americans? Is it people who live in America, or is it people who are American citizens? So let's say that we're saying American citizens. Okay, that's my population. So when it's talking about measurements, counts, all of that, no, the population is the group. The measurements are things that I will get about the population, but the actual population itself is the group Americans. Or for example, if my population was USF students, that is the group of interest. Okay? Now there's two types of populations. There's finite and there's infinite. So finite means that there's basically some starting and stopping point. There is a set number to them. This means basically that it can be counted. Now, I want to be careful with that term because we will talk later on a little bit. I'll use this term a little bit, which is where we have something called countably infinite. But for now, think of finite as there is a set number. And we'll talk more again about discrete numbers, stuff like that, but they're generally discrete, meaning that you can count them. And there's a set end point to it. So for example, if I have USF students, this is finite data because I could go and I could count student 1, student 2, student 3, all the way up to the last student. And I could count every single student at USF. Where an infinite population would be one where I can't actually count it. Now, this could be because the data is continuous, so technically there's an infinite number of possibilities, or this could be something where it's constantly changing or growing, where you can't actually have any way where there's a beginning and end in some discrete countable sense. So for now, just know that there's two types of population, finite and infinite. And generally in the real world, we're dealing with finite populations, but we don't have to. A sample is a set of individuals selected from the population, usually intended to represent the population in a research study. This is a subset or a part of our population. So, for example, let's say that this circle here represents our population. And I'm going to put big N to represent the population size. So this might be something like people who go to USF. And then I'm going to take some samples. Let's say that I sample some subgroup of these people who are students at USF. So this will be my sample. And it is going to have size little n. So big N represents the entire group of interest. This is who I actually want to say something about. My sample is a subset that I'm going to take to then try to learn about what I can from this. Hopefully this sample is representative of this population. And then hopefully I can make some inference about the population from that sample. Because remember we talked earlier about the fact that when you're looking at population data, it can be very costly. It can be very hard to actually go out and get that data, or it might even be impossible depending on what resources you have available. So the key aspect is that we want to take some sample, which is a subset of our population, and we specifically want it to be representative of that population. So we want this sample to be able to represent that population. And this can actually be very hard, right? Because again, let's say that we looked at USF students. We would have to make sure that we have students straight out of high school, returning students, non-traditional students, students who are part-time, people who are auditing, people who commute, people who live on campus, people who go to the different campuses, all sorts of situations for it to be actually representative of the student body, right? So we'd have to make sure we have, pretty representative sample. It may not be 100%, but the idea is we want it to be as representative as possible. Now, a parameter is a numerical description of a population characteristic. So if this big circle represents our population data, a parameter is describing something about this population. So this might be, for example, if the population is all USF students, this could be the GPA of all USF students. A statistic is a numerical description of the sample characteristic. That means that a statistic is saying something about our sample. So a statistic is actually an estimate of this parameter. Because remember, the whole point of statistics, hence the name, is that we are trying to use some point estimate, which is a statistic, and then we're trying to say something about the population, which is why it's so important that we have a representative sample, because we want our statistic to be as accurate as possible in saying something about that population. So a blank is a numerical description of a population characteristic. So we just talked about this. That would be a parameter. A blank is a numerical description of a sample characteristic. So sample means that it is a statistic, because a statistic describes something about the sample, which is why the field is called statistics, because we usually are focusing on our sample data. We're not generally looking at population data, because if we have the population data, we already have the answer for most cases. We don't need to do much to say anything because we have all the information right there. But when we take a sample, we then have to actually look at things like, is it representative? Is it descriptive? Do we have a big enough sample? Things like that. So you could say, for example, that parameter is to population as statistic is to sample. And this is sort of a rough drawing that I did on the computer to kind of show exactly what I just drew here, right? So we have population with size capital N. A parameter will describe that population. And we have sample of size little n, where a statistic describes something about that sample. Now, one thing you may notice here is for population and sample, right? So population, we have our parameter. For a sample, we have our statistic. Now, when we're looking at size, our population parameter is capital N. Our sample is little n. But when we look at mean, which is just a way of saying an average, for the population, it is the Greek character mu. The symbol that we use for the sample statistic is x bar. Now, another way you may see this, though, is you may see a statistic as the parameter where we just put a little hat over it. This is a way of describing what's called a point estimate. Because remember, the whole point of getting this statistic is to try to infer something about this population parameter. So if I don't have a special symbol for it, like x bar, I might just use the parameter and put a little hat over it to describe that it is not the parameter, it is an estimate of the parameter, meaning it's a statistic. But for mean, we do have a specific symbol we generally use, which is x bar. So that is generally what you will see in this course is x bar. Now, for standard deviation, we have, for the population parameter, it is sigma, the Greek character sigma. For our sample statistic, it is S. For variance, we have sigma squared. For our sample statistic, we have S squared. And then, of course, for proportion, we have, it's actually a row. So it's not a P, it's a row. It's like a P, but with a tail. So you'll notice that all of these are, for our population parameters, are Greek characters. Generally, for our sample, they're going to be, or for our statistic, they're going to be English characters, usually with possibly some symbol, like X bar or P hat, right? Things like that. So generally, our population parameter will be a Greek character, and our sample statistic will generally be either an English character, maybe with some symbol with it, or it'll be the parameter that we're interested in with a hat over it to represent that it is a point estimate. So population, it is a collection of blank individuals, outcomes, responses, measurements, or counts that are of interest. Well, because it's population, this means that it is all of the individuals' outcomes and everything like that. Sample is a blank or part of the population, so it is a subset of the population. So a sample can also be thought of as a set of individuals selected from the population, usually intended to represent the population in a research study. Now, note, it says here, samples must be representative of a population of interest, and sample data must be collected using an appropriate method. Now, this word must, I feel like, is a little strong. So I would say is the intention is that samples should be representative of our population, and we should use the appropriate method. Now, why do I use the term should versus must? Well, this has to do with the fact that oftentimes it's kind of out of our control to some degree. So what we're going to do is we're going to do the steps we can to be as representative as possible and use the most appropriate method. But later on, when we actually look at sampling methods, you'll see that that's not always so easy. And also, in statistics, one thing you will learn is that there's always going to be some unknown, some randomness to it. So even if you take all the steps you can to make sure that something is representative, it still may not be representative of that population. And that's why we'll talk later about this, about things like replication and stuff, because you might do all the right steps and still get non-representative sample. Okay, so now let's look at an example, sample versus population. In a survey, 751 employees in the United States were asked how stressed they feel at work. Of the 751 respondents, 616 said they feel at least a little stressed at work. Identify the population and sample and describe the data set. Okay, so in this case, we are taking a survey of 751 employees. So this actually is a sample, the 751 employees, representing a group that we're hoping is representative of our actual population, workers in the United States probably. Now, the reason I specifically know that the sample is those 751 is because another term we'll define later, survey, is actually represents that we took a sample. Okay, so just to jump ahead a little bit, a survey is when you go and question or get data for a sample. A census is when you go and gather data for the entire population. So every 10 years, the US does a census of everyone living in the United States. So the fact that we did a survey means that those 751 employees are in fact a sample, meaning my population would be all employees based on whatever group of interest. All American employees, all employees of the world, something like that. All employees in the state, it's not specific. It says in the United States, so our population would be workers in the United States. Our data set would be the outcomes or measurements from those people who are surveyed. So we ask them, how stressed are you? Maybe we have like a 5-point scale. Not stressed at all, little stressed, stressed, very stressed, extremely. And we get a survey we get the results. Those results are our data set. Okay, example 2, sample or population. So number 1, the salary of each employee in a mathematics department. So based on the way this question is set up, it depends on whether this is a sample or a population. Now, I am guessing by the way that it's written that we're interested specifically in the salaries of those people in the mathematics department. So I would say that this is in fact a population if that's the case. Now, this could be a sample of all math faculty in various schools or all faculty in the school, but based on how it's written and we don't have this extra information, I would say that this is probably a population data set. Number 2, the amount of energy collected from every solar panel in a photovoltaic power plant. Okay, so now this one, it has the word every, so this leads me to believe that again, this is probably a population, specifically the population of all of the photovoltaic power cell, all the solar panels in this particular photovoltaic power plant. That being said, this could be a sample of a group of photovoltaic power plants. So again, usually when you have a population, it could also be a sample of something bigger, right? So I keep talking a lot of times about Americans or US citizens. Well, guess what? Even if that's my population, if I'm looking at global trends, that is a sample of a much bigger population. Now, the third one is more specific. A survey of 250 members from an organization union of over 2,000 members. So in this case, one, it's got that word survey. That means it's it's a sample, but also it's specifically 250 members of a union of 2,000, meaning it is a subset of that 2,000 member union, meaning that it is a sample. Okay, number 4, the carbon monoxide level of 12 of 49 people who escaped a burning building. So in this case, again, it's a subgroup. It's 12 of the total 49, meaning that it is in fact a sample. Okay, so we're going to stop here and then we'll continue on in the next video. Thank you for watching. To continue learning, click the linked video here for the next lesson. If there's a topic you'd like me to cover, let me know in the comments. Don't forget to subscribe, and I'll see you in the next video.